Hi everybody, Mark Kirby again. This time I want to talk about some of the tools, Excel tools that you're going to want to use to do Chapter 18. Chapter 18 focuses on depreciation. If you've taken Accounting 151A, we focused primarily on straight line depreciation. If you've taken 1A, we've looked at double declining, which is really just twice the straight line. One of the other ones that we've talked about is units of production. And there's also something called sum of the year's digits. Sum of the year's digits. If you ever doubted whether or not I was working from a script, now you know I'm doing this with no net. Okay. So straight line depreciation, we all remember the formula. It's cost minus salvage value divided by the life. Okay? Let's see. So, units of production is where we take and we estimate the life of the product, the life of the machine in units. So we take UNITS, units. I don't know what UNTIS is. And that's where we calculate cost minus salvage divide by the life in units, and then that'll give us some number, and every year we multiply that times the actual units. Okay? The double declining method is really, straight line, twice the straight line rate. It's based on cost minus salvage divided by the life times 2. The book does it slightly different. They do, the formula is 100% divided by life times 2. If you think about it, all they're doing is calculating a percentage. So if the 100% represents the full amount that you're going to depreciate, say the cost is 10,000 and the salvage is 2, that gives you 8, right? 8,000. 8,000 is your 100%. 8,000 divided by 4 years is 2,000 a year. Okay, so 2,000 a year is 1/4, or 25% of the 8,000. So all they're doing is 100% divided by 4 years, which is what I did here, gives you 25% a year times 2. Your depreciation is 50,000. It's a complicated way of doing it. That's why I like just going cost minus salvage divided by life times 2. Okay? Sum of the year's digits is a different formula. It's another accelerated depreciation method, just like double declining is. This is a standard. Units is a standard. Double declining is accelerated because you depreciate more in the early years. Sum of the year's digits also depreciates more in the early years. And it's based on how many years the asset's going to be around. So to do sum of the year's digits, you're going to sit down and calculate, say it's you'll need to know cost, salvage, life, just like the others. But where we're going to start is if the number of years the asset's going to be around, let's say it's a 5-year asset, 1 year, 2 year, 3 year, 4 year, 5 years, you're going to take a fraction, which is, and I'm going to do this as text, the total of all of the years that it's going to be around is 15. It should be 15. Yeah, I'm smart. So year 1, there's 5 years remaining divided by the total number of years. That's why I do it as text. 5 divided by 15. So the formula is years remaining divided by total years. Let's call it what they call it, sum of years. And it gives you this fraction, this 5 divided by 15. 5 years to go out of 15 total. Okay? And that the bottom number here, the denominator of the fraction, doesn't ever change. So in year 2, my fraction would be, there's 4 years left, right? This year, this year, this year, and this year. So it would be 4 divided by 15. The following year it would be 3 divided by 15. 2 divided by 15. 15. And last year would be 1 divided by 15. And you would multiply that times the cost minus the salvage value. Where am I going to type that in? Cost minus salvage. So if we had a cost of, say, $50,000, salvage value of $5,000. Okay, life of 5 years. The sum of the years digit calculation would be 5 divided by 15 times plus 50 minus 5, $45,000. Okay, and that number would remain the same all the way down. So you'd get less depreciation each year. Okay? Okay, so let's do some examples here. I'm going to set up one set of data. And I'm going to borrow this. Okay. Cost, salvage. We're going to have one asset. Cost is $50,000, salvage is 5. Useful life is 5 years. I'm going to do a schedule. 1, 2, 3, 4, 5. And I'm going to do, let's see. Okay, so I need headers. Period. Depreciation expense. Accumulated. And book value. Boy, I cannot type today for anything. Okay. Center them, underline them. All right, so on a straight line system, let's put the header down here. We're going to do straight line, make it bold. Making it bold eventually, hopefully. Go to the Home tab, make it a little bigger. Okay, and your depreciation on the straight line is plus cost minus salvage, divide by life, I can format all of these real quick. And since my depreciation is the same for all 5 years, I can just point to the cell above. Oops. fine, fix it. My accumulated depreciation the first year is 49,000. I'm gonna move this a little bit. I'm gonna make a change here real quick because I want to show a period 0. In period 0, my book value is 50, correct? So my accumulated depreciation in year 1 is just the first year. In year 2, it's the total before it plus the current year, and all the others are the same. And my, hey, how's my depreciation? $49,000. You probably caught that before me. But it's the math operands. It's the priority of operations. Excel will take plus B12 minus B13 divided by B14. What it's doing is it does the multiplication and division first. So it's taking B13, which is 5,000, dividing by 5. So it's taking 50,000 to minus 1,000, which is wrong. So to fix that, we're going to have to put in parentheses here and here to do the math. 50,000 minus 5,000 first, divided by 5. So 45,000 divided by 5 is 9. That's right. Okay. So all of a sudden my math is now working better because of the priority of operations. Okay? So my book value is beginning book value minus accumulated depreciation. Now I can copy this down if I lock my reference to the beginning book value. That way when I copy this to the next few cells, I take beginning book value minus accumulated, beginning minus accumulated, and so on, to get my ending book value of 5,000. And I don't go below 5,000 because that's my salvage value. Okay? Now let's change this up. I'm going to take the template here, and I'm again going to pull it down a little bit so that nothing gets in the way going across. I'm going to copy my template and plug it here, and we're going to do double declining. What's it doing? So I'm going to go and pull all of my formulas. Let's see. I want my book value, again, I'm using the same numbers, cost 50, salvage 5, life 5. I just have to fix my formulas here. But my depreciation method's different this time. My depreciation method is my cost plus cost minus salvage. And again, remember, order of calculations, I need to put those in parentheses. Divide by life times 2. Notice my depreciation is $18,000. Does that work? No. Why am I trying to copy the formula down? It doesn't work. And it doesn't work because I've made one major boo-boo. The double declining does not take salvage value into account until the very end. It doesn't become part of the formula. So what I've shown you here up above, and I hope you caught me on it earlier, is wrong. That's what you get for doing this late on a Saturday night, I guess, huh? And nobody's perfect. We'll work our way through it. So my formula needs to change a little bit in that I just have plus cost B12 divided by life 5 times 2. So my depreciation in the first year is $20,000. Okay? So the first year's depreciation is $20,000 based on 5,000, the original cost, 50,000, I'm sorry, divided by 5 years, which is 10,000 a year, times 2. The other thing that I've neglected to mention is that double declining, because of the fact that it's declining, we need to be working off of not the same cost, original cost every year, but the actual book value. So let me kind of start from scratch and go through a little bit more detail and recount the double declining method for you here. I'm going to take this out. Okay, so double declining is your book value divided by life times 2. It works out to be what the book was showing you, that it's a percentage. So the way to look at it is you take the original cost of the asset, but you treat it as 100% and divide by its life. So if I have a 100% asset, the total cost with a 5-year life, what's 100% divided by 5? It's 20%. So in a straight line world, you'd be depreciating 20% a year. In double declining, you multiply that by 2, you depreciate 40% a year, but it's 40% of the book value. Okay? So what we've done here is taken 40% of the book value. In year 0, the cost was $50,000, ignored salvage value. 40% of that's 20. So for the second year, the amount I'm applying my ratios against is $30,000, the book value that was left at the end of year 1. So plus 30 divided by 5 times 2 gives me 12. And in year 3, it's, notice at that point, 30,000 minus 12 leaves me 18,000. So at the end of the year 3 depreciation is the 18,000 book value that was left, divided by 5 times 2. 7,200 leaves me book value of 10,008. Year 4 depreciation, the 10,8 divided by 5 times 2 leaves me book value of 6,480. Year 5 depreciation is the 6,480 divided by 5 times 2 is $2,592. This leaves me a book value of $3,888. Well, here's where the salvage value comes into play. Remember that our salvage value is $5,000. So our book value can never go below $5,000, which means we modify the last year's depreciation to get us so that our ending book value is $5,000. Our accumulated depreciation would have to be $45,000, and therefore our real year 5 depreciation would be $1,112, leaving us accumulated depreciation of $45,000 and a book value of $5,000. Sorry for taking the long way to get here, but this is how it's going to work. This is how double declining works. So the formula is book value divided by the life in years times 2, and that's how it'll work for Excel. You could use the same method we used up here, where we calculated 100% of the value, 100% of the cost divided by 5 years got us 20%. Times 2 got us 40, and watch what I do here. I'm going to just use 40%. Plus 50 times 0.4 got me the same depreciation I calculated. plus 30 times 0.4 got me the same depreciation I calculated, plus 18 times 0.4, same depreciation. It gets you there. I'm just doing it in a little bit more practical, what I think is a more practical method in Excel. Okay? Let's copy this and move on and do, I'm going to do units of production, but I need one more column. Units of production, and I need the actual units. So we're going to need to know the actual units produced. Undo that, center that, come down one, underline. Okay. So I'm going to remove my formulas. In units of production, we need to know one more thing that we don't know over here in our original data. Life says 5 years, but I need to know life in units. And let's say my life in units is, just call it 30,000. So I'm expecting this machine to make 30,000 parts before it falls apart and is no good anymore. My beginning book value is 50,000 bucks. My units in the first year, let's say, are 20,000. No, it's a 30,000 life. My units in the first year are, say, 10. Everybody's excited, so we produce a lot. In year 2, it's only 8. I'm going to put a little math down here so that I can double check and make sure I don't go over 30. I'm at 18. In year 3, it's, say, 6,000 units. In year 4, it's 4,000. And in year 5, it's only 2,000 units. Okay? And those are the units we actually produce on this machine. So with units of production, the salvage value is included. So our formula, we're going to now apply a fixed rate to every unit that was produced. So think about this. Our cost per unit is our cost minus our salvage value, which is 45,000, divided by the total number of units that we're going to produce. So for every unit that we produce, it costs us $1.50 in the original value of the machine. Okay? So to calculate my depreciation for units of production, it would be plus, remember, order of operations, parentheses, cost, minus salvage value, close my parentheses, divided by life in units, times the number of units produced in the current year. So my depreciation in the first year is $15,000, and that's based on $1.50 a unit times 10,000. Okay? And for year 2, my depreciation would be plus cost minus salvage, cancel, minus salvage, order of operations, divide by life in units times the actual units produced. My depreciation expense is $12,000. Now I need to clean this up a little bit. If I lock my cell references for cost minus salvage value and the life in units, notice how I did that up here, $B, $12 minus $B, $13, divided by $B, $15, because these never change. In any of my formulas, I can now copy this formula down, and it refers to those, and it multiplies by the actual units every year. And notice what happens. My depreciation goes from 15,000 the first year to 12 in the second, to 9 in the third, 6,000 in the fourth, 5,000 in the final year. My accumulated depreciation goes to 45,000. my ending book value is 5,000, which is the salvage value. So I'm getting the desired ending book value here. You got to remember though that if I put in too many units and I try and depreciate more actual units, my depreciation will fall below book value. So you need to have some sort of a test or limiter to know to stop at 30,000 units. Okay? Now I guess would be a good time. Notice what I had to do here. Okay, sorry, got interrupted there. So what I was about to point out was, look at what I had to do here to make this formula work. I'm actually going to copy up. All of the depreciation formulas here rely on the same thing. Excuse me, cost, salvage value, life in units. So I have to lock my cell reference to refer to these, and then I can copy my formula down. The other thing that we could have done here, always remember and don't ever forget our friend, the name manager. I could simply call this cell cost, add a new one, call that one salvage, and have it refer to salvage, add a new one, have it be life, no spaces, sorry. You can underscore though, life years, have it refer to life in years, and yep, then I could have a new one, life units, and have it refer to the life in units. Set up a few named ranges, and then I can come up here and very simply replace B12 with cost minus salvage. I'm going to accept its offer. Salvage divided by life in units. Pick the one I want. Hit enter. Those are static references. They don't move. So I can copy that formula down and it works everywhere. I don't need my dollar signs to fix my references. Okay, so that's how the units of production would work. Let's do a sum of the year's digits. Excuse me. So we're going to change this to actually say sum of the year's digits. And I won't have any units, so that can come out. But I could have my factor. We'll call it a factor, okay? And my factor is simply plus life minus the period I'm in. Notice what Excel just did. I'm going to do that again. I'm going to delete this cell. Watch carefully. Plus, I'm going to go point at life. And it says A4. I'm sorry, I pointed at the wrong cell. I want B4. And instead of telling me it's B4, it tells me it's life underscore years. It goes and gets the named reference for me. I didn't have to type in the name for the named range. Okay? So, I can copy that down. And what I'm trying to do, and I'm close but I'm not right, is approximate my 515, 415, 315, because my life is 5 years. So I'm going to have to refer to, I'm off by 1. There you go. We'll fix this all in a second. So now it's life minus the period before, which leaves me 5 years. The first year I have 5 years left. Second year I have 4, 3, 2, 1, and so on. So that'll give me my 5 15ths, 4 15ths, 3 15ths, 2 15ths, 1 15th. My depreciation is going to be calculated by taking my plus cost minus, notice Excel's filling this in for me, cost minus salvage times L15 divided by 15. My life was 5 years divided by 15, right? The other thing I could have done was come down here and given myself a total and said, you know, my sum of the year's digits is 15 instead of just manually typing it in. That way if my life changes, if it varies, then I can have an impact on that. Okay? I'm going to fix my reference there. Yeah. L15 divided by K. I want to fix my reference there. There we go. Do it right and it will do amazing things. Copy that down. So watch what happened. My beginning book value, which I did not change, which I did not fix, there. Well, that's another thing. Notice how as I copied this around, I had to fix book value every time. If I have it refer to the cell formula cost, when I copy it around, I'll copy this. Control C, Control V, Control V, Control V. Notice they all say cost and they all refer to this same cell up here. Again, I'm pointing with my finger, not with the mouse, so you don't see what I was doing. There. Okay, my original book value, 50. My depreciation is cost minus salvage value times 5 divided by 15 times L35 divided by K4. Copy that down. L36 divided by K41. L37 divided by K41. L38 divided by K41. So my accumulated depreciation goes from 15 in the first year to a total of 45 by the end. My book value at the end is $5,000. Now all of these are set up as formulas. All of them. Which is really what we're trying to do in this class. Let's change some things. I'm going to change my life to 3 years. Okay? Notice what happened. Units of production didn't change because it's driven by units. However, I should have used up the 30,000 units in the first 3 years. Did I? No. There's a challenge. My straight line depreciation depreciated the whole value over the first 3 years like it's supposed to, and then went negative. I kept going. So my schedule, I would, eventually someday want it to stop and not have to, I want it to stop manually. No, automatically, so I don't have to do it manually. Okay? Okay, my double declining depreciation calculates properly in years 1, 2, and 3. And then it keeps going because it doesn't know to stop at 5,000. And it depreciates me down to a book value of 2160 because I have formulas all the way down through year 5. Sum of the year's digits correctly calculates for 3 years, 1, 2, 3. Doesn't get my book value down to where I want it to. And then continues on and my depreciation actually becomes 0 and negative. So I got some issues here that we would have to deal with to make this truly a universal solution. And let's look at how we can address that, okay? But to fix this, we're going to take this in baby steps, okay? So I want to show you, so far I've showed you how to go ahead and use Excel to actually just do the math, but you're plugging in the formulas here in each of these different scenarios. big part of what this class is about is the Excel functions. So, you know, what Excel functions can help us do this? I'm going to go to the function manager. Let's assume we want to do straight line. Go to the formulas tab, insert function, and go straight line depreciation. And it goes and finds me VDB. Let's see, returns the depreciation of an asset including partial periods. No, too complicated. SLN, that even sounds like straight line. Returns the straight line depreciation of an asset for one period. Here we go. There's a function for it. Hit OK. The function wizard pops up. So notice it started to fill it in for me. Equals SLN, open parentheses. Cost is cost. Salvage is cost. Salvage life. And it calculates it for me. My depreciation is $15,000 per period for one period. Click OK. It's done it for me. It's even put it in dollar signs, even though I don't want that. So I can use that equals SLN formula in place of you know, this formula I did here where I did cost minus salvage value divided by life on my own. Excel will do it for me. Straight line, let's see, double declining. Go up to insert function, type in double declining. DDB, double declining balance, returns the depreciation of an asset for a specified period using the double declining balance method or some other method you specify. I'll show you as we go through it. This one's a little more robust. Cost, I'm going to plug in cost. Notice it's automatically filling in the named range we've already selected, which is kind of cool. Salvage fills in the named range for the salvage. Life in years. And then it wants period. What period am I in? Okay, I'm going to plug in 1. Period is the period for which you want to calculate the depreciation. Remember, on double declining, the depreciation amount declines over time based on what period you're in. Okay, factor. Here's where this function makes itself even more useful. It doesn't just do double declining. Factor is the rate at which the balance declines. If factor is omitted, it is assumed to be 2, which is double declining. I could put in 3 and make this triple declining, or 4 and make this whatever you would call that, or 5 or whatever. You could make it really decline very, very fast. I'm going to leave it alone and just call it double declining for now. Okay? I'm also going to turn this back to 5 so that our functions, our formulas that we built up here work, so that I can compare what Excel is spitting out to them. So notice straight line depreciation matches, double declining because I put in the first period matches, units of production. I'm going to skip that one. Let's go to some of the year's digits. And go look for a function that says sum of the year's digits. SYD. Returns the sum of the year's depreciation for a specified period. Plug in cost, plug in salvage, plug in my life in years. And remember, some of the year's digits is that one divide, or the current year, the number of years remaining divided by the total of all the years. In our case, it was 5 over 15, 4 over 15. So what period am I in? Let's pick one. Let's call it the third period. Tells me what my answer is going to be. 9,000. If I come over here and look, 9 matches 9,000. I'm doing good there. Let's put in period 1 and I get 15,000, it matches. It's giving me the same numbers as what I calculated manually. Okay? Now let's address units of production. Function, do a search for units of production, and it says, please rephrase your question. Excel does not have a built-in function for the units of production. Okay? So what we did over here, where we built our own little formula, is the best you can do. Good? Okay. So we can now replace our existing formulas with these Excel functions that we now know exist. And to do that, I'm going to just copy this down, and my depreciation is going to be equals SLN. Notice I'm doing it manually. It prompts me for cost, comma, prompts me for salvage value, comma, prompts me for life. Hit enter. I can even take that and copy that all the way down, because all of those are named ranges, static references that don't move. So there's my straight line depreciation for a 5-year period. If I go 3, it calculates the depreciation for each of the years, and I still have that problem where it goes negative. Okay? We're going to address that in a second, but I want to go through the functions first. Double declining. My double declining depreciation, I'm going to take out all of the hand-built formulas that I did, and I'm going to put in equals DDB, which is the Excel function. It's going to prompt me for cost. See, it highlights salvage, prompts me for salvage, prompts me for life, and prompts me for what period I'm in. I can just point at the line right here next to me, right? Because I numbered all my periods. Close parentheses, hit enter, and I can copy that formula down, and each year the period refers to the next one down, the next one down, the next one down. So it calculates this correctly for me. Okay? I'm going to have to move some of the year's digits to fit this all on one page. We're going to skip units of production. We're going to plug in some of the year's digits. And I can do away with my factor column. I can do away with my depreciation calculation column. And I can now come in here and go equals sum of the year's digits. See, it even prompts me, open parentheses, prompts me for cost, comma, prompts me for salvage value, comma, prompts me for the life, and it also wants to know what period I'm in. So I can just refer to my list of what period I'm in. Enter. I didn't have to calculate a factor, and notice it gives me, and I can copy that down, it gives me the right number all the way down. Okay? Did the double declining, oh, I neglected to point something out. Look at the double declining again. Up above, we had to manually adjust to get it to stop at book value. In double declining, look what it did for you. It automatically did it. Oh, and my math up above was wrong, so shows you I'm a genius, right? Yeah, I did some bad math here, between here and here. But it knows to stop and get you right to the 5,000 without having to do any funky monkey or messing around. It does it for you. So those are the advantages of using the functions built into Excel. Okay, I'm going to get rid of these little examples because I've now duplicated them up here. Remember, there is no units of production function in Excel. So let's address the problem that I brought up earlier. If my life changes to, let's make it extreme, 1 year. We built these cool little formulas of our own. Book value, your depreciation in 1 year, cost minus salvage divided by 1. You eat it all up in 1 year. Notice it still goes negative. It continues to depreciate because we threw in 5 years. When we use the functions, it does the same thing. How can we deal with that? Here's a little trick I want to throw at you. And you start with the first line. I'm going to hit F2 to edit this. Remember our old buddy, the if statement? He's back. He's powerful. If prior book value is less than or equal to salvage value, then give me 0 for the current depreciation. If my prior book value is greater than salvage value, then go ahead and do the calculation like you normally would. Uh-oh. What have I done? There we go. I want to go to the end and put another close parentheses because notice I've added open 1, open 2, close 1, close 2. So I'm going to copy that formula down. But all I did is put in an if statement. Come up here to the top. If prior book value, which is cell D32, is less than or equal to salvage value, which in this case is 5,000, give me 0, meaning 0 depreciation for the current period. Otherwise, calculate the straight line based on cost, salvage value, life, and years. So look what just happened to my formula here, or my schedule. In year 1, it calculated depreciation of 45,000, cost minus salvage value, divided by 1, because I've got this extreme case of 1 year life going on, gets me to book value. At year 2, I have 0 depreciation, my accumulated doesn't change, and my book value doesn't change. Year 3, same thing. Okay, so I'm now good for periods 1 through 5. Or we could make this a 10-year asset, or make room for a potential 10-year asset. So now if I change this to a 4-year asset, or a 6-year asset, or a 7-year asset, or an 8-year asset, whoops, or all 10, 9, or so on. Okay? Everybody see how that one worked? Nice and neat. I, however, am kind of a perfectionist, so I have a problem with this. So what I would do is I would also fix it so that these disappear as well, and I call this the disappearing trick. A little Houdini work here. So in my accumulated depreciation, I'm going to go into probably the second cell here, because the first one's different. All the others are the same except for that first one. So go to the second cell. And again, my if statement is my best friend. If, and all I have to do is point at the cell next to it, right? If I calculated 0 depreciation already with my other if test, if that equals 0, then give me 0. Otherwise, go ahead and do the whole function that we had originally planned, and I'm going to get 0. And I'm going to copy that down. Look what that's done now. It's blown up and it's given me 50,000 in book value here. Why? Because my book value is my original book value. I'm going to move that down here, by the way. My original book value minus the accumulated. Well, my accumulated is 0, so I have a problem. It works here, though. So let's say we now are going to have to make it, and it fluctuates on and off and on and off and on and off. This is great. I'm going to depreciate the same asset every other year. That's not illegal or anything, is it? How do we fix this? Again, we're going to need another formula fix, and by now you should know. I'm going to tell you who's your best friend? The if statement. If, and go back and check depreciation, if the depreciation equals 0, then give me 0. So again, I force this to be blank. Oh, I didn't put in my second comma. Notice I didn't separate. If B33 is 0, give me 0 plus whatever. Well, it's not equal to 0. It's looking for that. What happens if false? You got to put in the comma to tell it, here's what happens if false. Okay, so that's good. Now I can copy that formula down, and it should clean up everything. So if I have 2 years, it shows 2. If I have 6 years, it shows 6. If I have 10, it shows all 10. Let's stick with the 1 as an extreme. Again, what do I do with all this? I'm a perfectionist, right? I don't want that floating around over there. I would start with 1, and we're gonna leave the 1, and we're gonna change the formula in the second column. And I'm gonna replace the number 2 with equals, guess who, if. If this, if your current depreciation equals 0, then 0. If not, then plus the cell above it plus 1, and it will count up for you, close parentheses. Now I can copy that down, and that column disappears. If I format it properly, it'll turn into dashes and disappear even more. 2 years, 3 years. Notice I have a small problem here. These don't line up. Being a perfectionist, I'm going to fix those. Year 0, I do want it to show up as a 0, so I'm going to have to format that differently. Right-click, format, number, general, go. Okay, I'll accept that. So I have 3 years up here. My life goes to 5, 7, 10, and they all fill in. Or in an extreme case, 1. Okay? Now the fun and exciting thing is, I could go over and do that to all of these. I'm not gonna. I'm going to let you do that in your homework, right? Because I want you to go to this level and make these really professional looking. Here's another one. We haven't talked about this in this class. I'm hoping you talked about it in Cabot 41 or what's the other one? Something 5. Drawn a blank. Oh well. I'm going to take all these cells in my new toy, and I'm going to do something called conditional formatting. On the Home tab, conditional formatting. Student showed me this little trick. I knew about conditional formatting, but I didn't ever think to use it for this. So, you know, we have all these dashes here. What if I don't want those to show up? What if I'm even more of a, what if you're more of a perfectionist than I am and you don't want these to show up? We're going to go set up a conditional formatting, which conditional formatting is like an if statement. If something happens, format the cells a certain way. So I want to format cells that contain a cell value equal to 0. And the format I want to set is the font color to be white. Okay, and I'm going to click OK. Now white will blend in with the background of Excel, and I'm going to click OK, and look at what just happened. All the cells are gone. When you do something like this, it is hugely important that you use cell protection to protect these, because someone, notice, look in the formula bar up at the top. I'm pointing with my finger and the mouse because it's so important. All of these cells look blank but have formulas in them, and as a result they have numbers in them. All I did was use conditional formatting to format them to white, which matches the background of Excel, so they totally appear to disappear. I can bring them all back in a heartbeat. I can make some of them go away. I can bring some of them back. I can bring more back. I can go to a 3-year asset. Okay? This is really, really powerful. This is something you can use when we do bonds or notes payable, when we do loan amortizations. This particular case, I'm going to go ahead and turn this back to 10 so I can see what I'm doing. But I could take these formulas and I could copy this down in case we wanted to have a, I don't know, I'm going to put in 50, a 50-year asset. Notice that I've only gotten to 30, 47, 48, 49, 50. There's a 50-year asset. Okay, you could treat this much like a loan. It could be a 50 payment loan, but if I have a 40-year life, notice my schedule stops at 40. If I have a 20-year life, my schedule stops at 20. Hugely, hugely, hugely helpful. Okay? I'm dying to ask if you have questions, but you don't. So if you do have questions, of course, please bring them to class. We'll go over them. Okay? Let me pause for a second. All right, so I thought about that for a second, and my thought was, well, if I taught you everything that you could possibly know at this point that would work with Chapter 18 in depreciation. And I thought of one more thing. Okay? If you are truly an overachiever, and you really, really want to go someplace with this, I'm going to go up here. Remember, this is our data input. I'm going to add depreciation method, and I can come over here and remember we have this great little thing called data validation. Data validation, and I'm just going to plug in here that oops, that's not what I want. I want a list of, what are they? SYD, sum of the year's digits, SLN, straight line, or DDB, double declining balance. And I've just created a little fill-in box here where you can select the type of depreciation you want. Okay, how would I use that? I'm going to go back to a 5-year note, or note, sorry, 5-year life for my depreciation, and we're just going to use this little example down here. I'm going to even copy it. I'm going to put it over here so that you guys have this one to look at, but there's also this possibility here. Okay. And I'm going to mark it that this one is the one that works with the selector. And I'm going to do my normal thing and mark what all of my input fields are in blue, because I like that. Oh, hey, what happened here? That was supposed to turn yellow. Let's turn that yellow. Okay. So we're going to play here. Oh, and I probably messed this up by not copying that down a long, 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 long way. 50. Notice it didn't change. We're going to have to copy this down. There we go. Okay? Now I'm off and running. Turn it back to a 5-year life. Save it just in case. So here's what we can do. Based on the fact that we can come over and change type of depreciation we want, we now have a universal solution. This is the sweetest place you can get with Excel, is to have a universal solution. So what I want to do is have my depreciation calculate either straight line, sum of the year's digits, or double declining, depending on which one I choose in my input. To do that, we're going to rely on our old friend, the if statement. So remember, we started up here. I'm going to hit F2. If N32 is less than or equal to salvage value, I'm testing to see if, do we stop? This is my stop test from here to here. Okay? And if it's not, it's automatically defaulting to straight line. Well, I'm going to make a little change here. Now I'm going to say, instead of defaulting, I'm going to go if, actually I'm going to back up a second. I'm going to name this range. Okay, just to make this easy. Formula, name manager, new, and I'm not going to call it SLN, I'm going to call it DM for depreciation method. Okay, close that. So back over here, I have if N32 is less than salvage value. So this is my decision maker. Do I stop? If book value is salvage value or less, depreciation is 0 from here on out. If it's not, instead of defaulting right to SLN, go with a new if. If DB, depreciation method, equals put it in brackets or quotes, SLN, then calculate straight line. And I can leave the formula in there. Okay? So if test for stop, then test for is my depreciation method straight line. If so, calculate straight line. Okay? So notice I'm inside of a new if. Open parentheses 1, open parentheses 2, open parentheses 3, close. So I'm at 2. So I'm finishing this if. So what's the if not? If it's not straight line, comma, do another test. If depreciation method equals, which one do we want to do next? SYD, sum of the year's digits, open parentheses, then based on the cost, notice it's prompting you for all of this. Cost, comma, salvage value, comma, life, comma, what period am I in? I can just refer to the period right here. Calculate the sum of the year's digits. Okay? So if it's not straight line, test to see if it's, got to put it in quotes, sorry, sum of the year's digits. What if it's not sum of the year's digits? Then I could test to see if it's double declining balance, right? If DM, notice it's given me my options down here, if DM equals DDB, double declining balance, then calculate DDB of, and it starts to prompt me, cost, comma, salvage, comma, life, comma, what period am I in? Still in period 1. End. Oops, hang on. Else, what do we do if it's not? So we've done this test. Is it, I was pointing with my finger, is it straight line? No. Is it sum of the year's digits? No. Is it double declining? What to do if yes, comma, what to do if no? Well, we've run out of options, right? It's got to be one of those. But just in case, tell me I've got a mistake. Tell me I've got an error. Okay? So close parentheses on that. Let's work through this. 1 open, 2 open, 3, 2, 3, 2, 3, 4, 3, 2, 1, 0. Let's see if my edits are correct. Nope, I got a boo-boo. Let's see. What is it telling me my error is? I'm going to have to kind of edit through this because it's not helping me. I now have what's a rather long, look up at the top, long formula. So if, I know my if test works, if dm equals sln, and I know that worked, just in case, because we used full caps in our data validation, I'm going to go ahead and put it in full caps. Let's see. If that's true, do this. Else, if this is true, I'm missing a comma right here. See it? If dm equals SYD cost. Now I need a comma right there. Hit enter. I still have a problem. I have multiple boo-boos. Oh, but it's given me a suggestion this time. Microsoft Excel found an error in the formula. Do you want to accept the description below? All they're doing is they're putting another 1, 2, 3, 4. They're putting another parenthesis on the end. I accept. Okay? And I can copy that formula down because I'm testing prior book value and I'm using the current period. The rest of these are all named ranges that I'm using, so they're all static reference. So this is totally copyable down, and it works. Now let's change and see what happens. Remember, we have our correct formulas and functions that we've already used. Okay, so I've got something to compare to. When I've used this great big formula and I've set it up as a universal selection, universal tool, and I picked straight line, it works. It came out the same. This one is the same as this one, yes? So let's change this thing. Sum of the year's digits. Ah, it blew up. I've got a problem. All right, we'll go fix that in a second. Let's change double declining and see if it blows up. It also blows up. All right, part of the fun of this is figuring out what the heck you did wrong. What I did wrong in this case, right? So let's go play. We know that our first formula for straight line is correct. Okay, let's test it. Let's go all the way to 50 years. Look, it's correct. I don't have a problem. Okay? If we go to double declining, it blows up. I'm going to keep the years short because they're easier to edit that way. And notice when it blows up, it doesn't make all these lines blank out. So we've got to go and look and see where I made my boo-boo. And I know it's not in the test here. And I know it's not in the test for straight line here, or the calculation of straight line. I know it's in if double declining, then double declining cost minus cost, salvage, life, K32. Oh, do you see it? I see it. You may not. I made an assumption and I forgot about the factor. See how in the double declining formula it wants cost. I gave it cost. Salvage, I gave it salvage. Life, I gave it life in years. Period, I gave it K33, which is what I want because that's 1 right now. And then I gave it a factor of error, which is wrong. I need to put a comma there so that my factor is 0. I need to end the calculation for double declining. Then I need another comma to get me what to do if it's false. Okay, what to do if the if is false. Sometimes these get a little crazy on you. I've entered too many arguments. My factor is, oh, I didn't need the second comma. Sorry. There, now it works. Now I just have num. It's time to stop and refer to our calculation here. Cost, salvage value, life in years, F33, comma, factor, which I'm leaving blank, hit enter, and it gives me num. You've got to put in a factor is what that tells me. And that's why this is blowing up on me. Oh, the other thing I can do, because I'm being stupid, because it's late on a Saturday. You guys are having fun, I'm working late on a Saturday. If I take that comma out, it'll assume that the factor is blank, which gives you double declining. And now I've really blown it up. Let's see. I'm going to undo that. Put the error back in. Okay. Take that out. So my factor is blank, so it's double declining. Okay. If this is true, calculate that. If it's not, then give me the term error. Hit enter, go. Circular reference. This is, by the way, the worst thing you can have happen to yourself. Something is referring to, I'm referring to something that is calculated from the something I'm calculating. It's bad. Click cancel. Okay. I don't want to create a circular reference. Oh, the problem is I'm testing this formula here. This is what it's telling me. If L34 is 0, but now that I'm using double declining, remember when I use the period in double declining and in some of the years digits, it is looking to use this. So I've created a circular reference because I'm testing to see if depreciation is 0. So I need to change my test. If L34 is 0, I need to change that to what the other tests all were. If my book value is less than or equal to salvage value, then 0. Otherwise, do that. And that'll fix my circular reference problem. Okay, so now I need to copy this formula all the way down. And notice all those great things disappeared there on me. Okay. So I fixed my test so that it's not, my test to plug in this column, the period column, isn't dependent upon this column, because this formula now refers to K3 in both the sum of the year's digits and the double declining calculation when it refers to the period. Okay, so I can't refer back and forth to the two because they're linked. So I did my test based off of book value. As long as book value is greater than or equal to, or is greater than salvage value, it'll calculate another number and fill in this column. So if I go 10 years, this plugs in. I've made a boo-boo somewhere. We'll figure this out, huh? At 5 years it works. At 8 years it works. No, at 8 years it keeps going. Okay, we've made a boo-boo somewhere. What's telling it to go ahead and keep going? It's still in the cost minus salvage value. And it's because, oh, you see it? Our accumulated depreciation here is $5,006. Right? So when it calculates that 9th year, there is no depreciation in the 9th year. And as a result, we're getting this error. Very nice. Very, very nice. Let us change our double declining and I'm going to come down to 10 years on my double declining over here. It's doing the same thing. I got to think about that one for just a second, okay? We'll come back to it. Let us now go and change this for sum of the years digits, and let's fix our sum of the years digits, okay? I'm going to go back to 5 years. Notice our double declining blows up after 5 years because we're at salvage value. Okay, so I know my problem with my depreciation can only be with sum of the years digits calculation, and it's because, notice what I've done. Again, this is from being tired. If depreciation method equals sum of the years digits, then do something, but it doesn't say what. I got to type in SYD here, and it should work fine. That was a simple fix. Okay, so it was a matter of syntax that I didn't put the Excel function in here that it needs to know what it's going to do with cost, salvage value, life, etc. Okay? Oh, another fun thing. If you're ever looking at a formula that goes really, really long, sometimes it'll take up 2 lines up here. And if I get this just right, notice how that selects this column. But if I do this, see how it turns double arrows? I can pull this down, and I can then see really big formulas that take up multiple lines by turning this double arrows, and you can drag it up and down. So if you build one that's really long, you can look at it that way. Let's put an 8 here. 8 works. So my sum of the years digits is working 50. Let's go all 50 and test it. And I need to change the name on this. I'm not conceited about it being an awesome thing when I'm done. So it works for sum of the years digits with all the years up to and including 50. Okay? Good. Okay, so now that that works, let's go back and figure out why our double declining doesn't work. Change this to double declining just so I can work on it. But again, it's not changing here, so I've got, oh, there's a key. I've got a clue. I've got a problem with the existing formula by itself. So it's not just what we did here. Thinking it goes 50,000, I've got 8 years, and I get to 5,006. There's not enough for year 9. Oh, that's because there is no year 9. One of the things about oh yeah, here's one of the traps. Again, I'm working with no net, and I make these numbers up as I go. With double declining, you need a salvage value that is large enough that you use up all of the depreciation by the last year. If you don't, you end up in the situation where you never depreciate the full amount that you intended to. And it's just a sheer factor of the formula. So we're taking 100% divided by life times 2, okay? So in this case, I'm going to come over here and go, I've got 100% divided by 8, and that equals 13. 13 times 2 is 26. Well, it's 25 because of rounding even. So this is 12.5%. It's never enough to fully depreciate. So for example, if I change the salvage value to 4,000 or 400, let's put 4,000, it still blows up. But if I change it to 6,000, notice it brings me right to 6,000. It knows that I'm good at the end of year 8 to go to 6,000. So I hate to explain it this way because it might seem like a cop-out, but it's not. It's just a function of the formula that, and asked me to draw the graph of this on the board at school. The depreciation drops very fast at the beginning, and then it flattens out so much that the percentage of a smaller and smaller and smaller number gets you closer and closer and closer to a flat line, and it never gets to your salvage value if the amount is too low. Let me stop the video for a second. I'm going to try and build a graph and show you that, okay? Hang on. Okay, here's my answer in under 5 minutes. I threw together a chart for us real quick. And this shows your depreciation over time. I went to 50 years because I was trying to use my existing data. But you can see the depreciation drops over time, and it drops and drops and drops. And notice how this starts to curve and flatten out down here. Okay? What really happens over time is that this line tends to then at some point really start to flatten out. Okay? A lot like this. Oh, it's got to stay on the chart. So as that really starts to straighten out, you end up with that never really getting to where you want it to be. It never goes down far enough to be the depreciation number. I'm sorry, the salvage value. So it never really goes below salvage value. It gets incrementally closer and closer and closer. Here's our data again over here. Notice period 1 depreciation. I'm just going to show you. I went to 50 years with the same data, double declining. Our depreciation goes 2000 down, 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 down. And remember, it's calculated off of the prior ending book value. And as that number gets smaller, the depreciation for each year gets smaller and smaller and smaller and smaller and smaller. And eventually you will approach almost a standstill. It'll continue to decline. But the point is, you've got to pick a salvage value that is high enough where someday you would cross it. Like up here when we calculated it manually, when we crossed the depreciation number, we had to, I'm going to change this back to 5, we had to manually fix this. Well, look, the computer is looking for a solution where they have to manually fix it to force it to 5,000, but they never get below 5,000, so it never fixes it. So on an 8-year asset, it's telling me, hey, your salvage value is too low, and this is going to blow up. So notice it got close at 5,006, but it wasn't below it, so it tried to keep going. So I could fix this by going to 5,100 bucks. Bang, solves the whole problem. But that's the problem, is salvage value wasn't small enough. Okay? So before I got there, what was I trying to show you? Oh, how to use our data validation to pick and come up with a universal solution using a bunch of if statements and named ranges. It makes it a lot easier so that we can calculate any of the different types of depreciation. And by doing that, I've blown up the other one too, but that's okay. Okay? So, you need to come up with one solution, or at least that's what I try to do. If we change this, we've got $1 million asset with a $100,000 salvage value. Notice my column's not wide enough for it. Now it's too wide. There we go. So I started 100 grand. It's an 8-year life. With some of the year's digits, it works its way down to 100 grand. With straight line, it works its way down to 100 grand. And with double declining, notice it gets close to the 100 grand, but not quite. So let's go start over again. Sum of the year's digits, $150,000 salvage value, works its way down. straight line, works its way down to 150 grand. Double declining balance, works its way down to 150 grand and stops. And it hits it in year 7 and even hits it a year ahead. Okay? You'll be working with problems out of the book. They will have already tested this to see if it's large enough to make it work. So as a result, you won't run into this on your homework. Don't worry about that. And we'll go from there. I hope you learned a lot from this. I hope you're comfortable with it, even though I had to jump around a couple of times and fix some of my own mistakes. And that's part of Excel. You know, as you type up these bigger formulas, you tend to make a boo-boo once in a while, which I did. It'd be nice to say I'm perfect, but I know I'm not. So play with it, try it out, take a stab at the homework. Any questions, bring them to class. Let's work on them in class. And I hope you enjoyed it. I hope you enjoyed the videos. Look forward to seeing you in class. Bye-bye.